Pressure. We already discussed about pressure back in our lesson in elasticity when we discussed about bulk stress. So when a fluid, either liquid or gas, is at rest, it exerts a force perpendicular to any surface in contact with it, such as a container wall or a body immersed into fluid. This is the force that you feel pressing on your legs when you dangle them in a swimming pool. While the fluid as a whole is at rest, the molecules that make up the fluid are in motion. The force exerted by the fluid is due to molecules colliding with their surroundings. We define pressure as the normal force per unit area. That is the ratio of the force uh, at respect with the surface area. So if the pressure is the same of all points of a finite plane surface with the area, then we have this formula. So the standard unit for pressure is Pascal, wherein 1 Pascal is equal to 1 Newton per squared meter. Other related units that use in meteorology are bar, wherein 1 bar is equal to 10 raised to 5 Pascal. And also millibar, wherein 1 millibar is equal to 100 Pascal. Another unit that used in pressure is the atmospheric pressure, wherein 1 atmospheric pressure or 1 atm is equal to 101,325 Pascal. So let's have our example problem. Suppose that the pressure acting on the back of a swimmer's hand is 1.2 times 10 raised to 5 Pascal. A realistic value near the bottom of the diving end of a pool. The surface area of the back of the hand is 8.4 times 10 raised to negative 3 squared meter. Determine the magnitude of the force that acts on it. So we have our um, given of 1.2 times 10 raised to 5 Pascal and 8.5 times 10 raised to negative 3 square meter. And we are looking for the force. So force is equal to pressure times area. So the pressure is equal to 1.2 times 10 raised to 5 Pascal. The area is equal to 8.4 times 10 raised to negative 3 square meter. So the square meter, the unit square meter will be cancelled out because we know that Pascal is equal to Newton over square meter. Therefore, the force is equal to 1 times 10 raised to 3 Newton. So the hand of the palm is downward, is oriented parallel to the bottom of the pool. Since the water pushes perpendicularly against the back of the hand, the force is directed downward in the drawing. This downward acting force is balanced by an upward acting force on the palm, so that the hand is in equilibrium. If the hand were rotated by 90 degrees, the directions of these forces would also be rotated by 90 degrees, always being perpendicular to the hand. So now let's discuss about the absolute pressure. So absolute pressure is a pressure of having no matter inside a space, or simply a perfect vacuum. So in getting the absolute pressure, it is equal to the atmospheric pressure plus the gauge pressure. So what is gauge pressure? It is measured in relation to ambient atmospheric pressure. Usually when we use using measuring devices such as manometer or barometer. Then we have the atmospheric pressure, which is the pressure of the Earth's atmosphere. So we know that the Earth's atmosphere is composed of layer of gases. So this layer of gases exerted force to the surface of the Earth. So this force produce pressure, which is what we call atmospheric pressure. So at sea level, the atmospheric pressure is equal to 1 atmosphere, which is equal to 1.013 times 10 raised to 5 Pascal, or specifically 101,325 Pascal. So in PSI, it is equal to 14.7 pound per square inches, or 14.7 PSI. Okay? So again, absolute pressure is the sum of the atmospheric pressure and the gauge pressure. So gauge pressure is one being measured using a device. So the negative value of a gauge pressure is what we call now the vacuum pressure. It is any pressure less than the local atmospheric pressure. So it is defined as the difference between the local atmospheric pressure and the point of measurement. So to visualize all of this diagram will help us to differentiate the absolute atmospheric, gauge, and vacuum pressure. So we can see here the barometric pressure is the other name for the atmospheric pressure. Again, barometric pressure is the atmospheric pressure. So the absolute zero pressure, starting here, and we have a constant value of atmospheric pressure. So any increase in the atmospheric pressure is what we call now the gauge pressure. Summing up the atmospheric pressure in the gauge pressure is equal to the total absolute pressure. So when the measured pressure is less than the atmospheric pressure, then we have a negative value of gauge pressure, or simply called vacuum. So the difference between the atmospheric pressure and the vacuum is also equal to our absolute pressure. So absolute pressure is being measured based on the zero pressure. So since the Earth has its constant atmospheric pressure, so it affects how we measure pressure. It can. So let's have our example problem. So a pressure gauge is being checked for accuracy. The gauge is connected to a tank that has an absolute pressure of 742.11 psi. What should the gauge read? So we know that the absolute pressure is equal to the atmospheric pressure plus the gauge pressure. So based on the problem, our absolute pressure is 732.11 psi, and we're looking for gauge. Therefore, the gauge pressure is equal to the absolute pressure minus the atmospheric pressure. Therefore, we have 742.11 psi minus the atmospheric pressure. So the atmospheric pressure in psi is equal to 14.7 psi. So getting the difference between the two quantities, we can now have the value of gauge pressure, which is equal to I am using my virtual calculator. Oops, not that one. Ayun. Mhm. And I will open our virtual calculator. Okay. So 742.11 minus 14 is equal to 8. So the value of gauge pressure is 72741 psi. Okay, what is our gauge pressure? Now let's try your understanding by solving this problem. So same problem with our example problem, but this time you're going to gauge, you will going to get the gauge pressure in terms of Pascal and atmospheric pressure.